Oh, welcome back to Sunday Science, everyone. And I gotta say, Strike, nice choice on the music.
You like that one?
That was nice.
That was nice.
Oh, glad you liked it. That's yeah, that's the new intro tunes.
I dig it. Hopefully we didn't get in trouble for the one that we were using when we started the series.
No, certainly not. Here,
Okay.
Let me get it.
At least you're not using show theme songs like what's his face used to, Antonio.
Oh. Anywho.
Indeed.
So, welcome back to Sunday Science, everyone. And yes, I know it's hard to believe Sunday Science is taking place on Sunday.
And not a Monday or a Tuesday.
Indeed. We're actually trying to follow a calendar this week. So I'm glad that you are all able to be here with us today and join us for our continuation on climate sciences. We have a fun mix today, from determining the amount of time that certain things have been frozen in desolate regions of the world to well, effectively, epic cow farts. So,
Epic cow farts as opposed to just regular cow farts, which are not near as exciting.
Normal cow farts are not very exciting.
These are big cows.
I've been on enough ranches throughout my life. I have a sister who actually is with the FDA as a PhD in agricultural sciences, and she gets all the cow farts imaginable as she inspects cattle coming across the border, things of that nature. And I'm not stating we're actually going to talk about cow farts, but for anyone that's curious, cow farts are primarily composed of methane, which is CH4. It's natural gas. And
but
as our climate changes, there are naturally occurring pockets of a multitude of things that wind up getting released into our atmosphere. And well, yeah, we'll get there after Steven. So Steven is going to start this show off with some pretty awesome information about ice core sampling and things more along the line of the geologic time scale, because sometimes it's difficult to remember how short of an amount of time we actually get to enjoy this awesome world that we are on. So I'm going to go ahead and hand things over to you at this point, Stephen.
Thanks, Andy. Just one quick question. Are cow farts mostly SPDs or no?
That I don't have any way of answering. So
okay. I'm just, these are two videos. I'm just going to do a quick intro here for both of them. Yes, this is more geology-oriented, showing how they retrieve ice cores, showing you the process. I think they're pretty good videos, and shows you how you can get air out of them and test to see what the atmosphere was like and things like that. I think that's all I want to say about it till after.
Okay.
Sweet.
Do you have a preference for which one you'd like first?
The Harvard one, which would be the third one, the second one that you know, or something like that, maybe.
That's so utterly unhelpful. If you have a title,
play. We'll figure it out.
Just hit play. All right. You've got Inside the Experiment, Abrupt Change in Ice Cores, yada yada, and Studying Ice Cores to Understand the Earth's Climate. Which one you want for? Pick one of those.
Studying Ice Cores to Understand the Earth's Climate.
All right, we're going to study some ice cores. Here we go.
One of the best ways to understand the Earth climate system as a whole is to look into the Earth's past and to look at different time periods in the Earth's climate history when greenhouse gases were at different levels. How much of the difference is really explained by the greenhouse gases themselves, how much is explained by other factors. And ice cores are among the best records to answer those questions. We collect ice cores both from Greenland and Antarctica. These are the two biggest ice sheets in the world, and the two ice sheets that contain really very, very old ice. If we drill down to the base of the Antarctic ice sheet, in some places ice has been recovered that's as old as 800,000 years. And so we drill ice cores to get this ancient ice to look at the record of Earth's past climate.
I had a background in chemistry, and I kind of wanted to get a better understanding of the dynamic system of the Earth. We can learn a lot about the climate by looking at the air and the ice. We can learn about how wet or dry it used to be. We can learn about how cold or hot it used to be by just analyzing what geochemical proxies are in the air or ice.
What you're looking at here behind me is a system that will take large volume air samples that are extracted from the ice. This is a system that essentially is a major step in the processing of samples on their way to getting measured for carbon-14, for getting these answers about questions like the past solar activity.
Just recently, we returned from an expedition to the center of the Greenland ice sheet. We were outside of Summit Station, and this is one of the most remote sites in the world. The question I get the most is, how cold was it? The first night we were there, it got down to -40, which is the same in both Fahrenheit and Celsius.
What we have here are boxes of ice cores from our recent expedition to the summit of Greenland. This particular set of ice cores is going to be used for carbon monoxide analyses also. These ice cores will get us back to about the year 1800 AD, so to the start of the Industrial Revolution, and we'll be able to really see the full history of carbon monoxide in the Northern Hemisphere and how it's changed over the course of the Industrial Revolution.
What we're really trying to do is just get a better understanding of the changes that we're observing on the planet. Because this climate change is not black and white. The Earth is a very dynamic system, and we can't study it in place, so sometimes we have to look back at proxy evidence and indirect evidence to gain a better understanding of how the Earth has been changing.
It's very important to understand how the climate system works so that we can predict where it's headed, and so that we can with confidence predict what are the conditions that would cause the system to really spin out of control.
A production of the University of Rochester. Please visit us online and subscribe to our channel for more videos.
You know, I gotta... Go ahead, Mel.
Well, I was going to say, how is it the same in Fahrenheit and Celsius? I just kind of stuck on that.
40 minus is just one of those things that happens.
Yeah, it's the intersection point where
Okay.
It's the same number, two different units of measure.
Okay.
Intriguing.
I haven't done the math, and I haven't thought that low down underneath 0, so...
We tend to
I
think
use
low
them
here.
both, so, you know. I'm still partial to Fahrenheit, though.
Yeah.
I do have to say, switching from SI to Imperial, the most difficult thing I've ever run into is temperature. Distance, I'm good with SI units. I would prefer the metric system all around, actually. Mass, same thing. Temperature, for some reason, it's really hard to think about it being 36 degrees outside, and that means that you need sunscreen.
Turn on the AC. Yeah.
That is me too. So I
Fahrenheit's just so messy, that's why, you know. I mean, and then in geology, we do more confusing things. Like, you know, if I want to publish a paper and everything, they make me do everything in metric, but all my field notes are in standard, because actually in the field, the foot is a more useful unit than the meter is. And of course, geologists, you know, we kind of borrowed this from the engineers. Instead of dividing feet into inches, we divide it into tenths and hundredths to even confuse everybody more.
Indeed.
Good.
There's nothing like a tenth of a foot.
It's hard to beat
a
that.
whole foot is just crazy. I'm thinking like
it's much more easy to walk a foot than it is to walk a meter.
Yeah.
You know, I don't have clown feet. I can't walk. I can't heel toe a meter. I can heel toe approximately a foot. It might not be exact, but it's a close estimate. It's a lot closer than maybe I was off by an inch over a foot one way or the other, and then I decided to walk 3 1/4 of them and called it a meter, and it's not even a yard, maybe. Or maybe it's a lot more than a meter.
Well, a meter stick is almost 3 yards, right?
It's over like 39 inches.
Yeah.
We're off to one
I really want clown feet to be a scientific unit of measurement now, just because that would be just amazing.
Oh, could you imagine what the Flurfers would do if they saw land surveyors using the clown foot as a unit measure?
All right.
Oh, I just want to say something about glaciers real quick before the next one.
Okay.
When glaciers build, there's something you got to remember. Technically, ice is a rock. And when they build, it's snow, seasonal snow over yada yada for millennia. And the reason why, even though Antarctica has had ice on it for about 20 million years, we think, you can't drill down and get a 20 million year old core, because as the glacier builds, glaciers, like anything else, are subject to the laws of physics. They can only really get so big. And eventually what happens is on the bottom, the friction and the pressure actually causes melting. So glaciers, they'll build at the top and they'll actually start melting on the bottom, and then they'll start sliding a little if they get thick enough. They'll start doing that. So I just wanted to explain that. That's why you can't get a 20 million year old ice core.
Good to know.
Is there also outward ice flow from the center while it's still semi-solid?
It is moving.
Yeah.
It is moving. But thinner glaciers, like the ones that covered North America, they probably, they moved pretty quickly, but they didn't have that melting as much on the bottom, but they also weren't here as long. And glaciers actually erode by plucking and abrading. They do not act like giant bulldozers. They don't do that.
Indeed. Alrighty.
It looks like we have a question from Jamie in the comments. Is 800,000 years the furthest back ice cores can go? I personally don't know how to answer that question, as I'm unsure as to that amount of time personally. Does anybody else have more information upon that?
Not right off the top of my head. I imagine it has to do, if we're going to look at ice cores, we have to look at the ice caps and how much of the old ice is retained in each individual flux, because we know we lose old ice now with every summer of the ice caps. We have that cap that shrinks down, so the access to the older ice is not it's not as accessible as it used to be. So I don't know what the time frame or the timestamp is in regard to the age of the ice that's left that hasn't been released into the environment from the fluctuations in temperature. So
Indeed, I'm not aware myself either. I know that we do have the ability through other sampling methods, such as seafloor sampling, and again, going back to you, Stephen, with much longer duration geological scales, that we are able to take samples from a much later point in time than 800,000 years. However, I'm going to have to actually sit down and do some homework on that one.
Well, I don't know the oldest that can.
Serves,
go ahead.
If memory serves, the 800,000 that they were talking about, that was actually gotten from the bottom of one of the thickest glaciers in Antarctica. So that seems to be the oldest, or was it Greenland? I forgot. Sorry. So it's it seems to be about as old as the oldest ice you can get. There might be a point where you might be able to go back 1 million years, but
there was an oddball one. There was one that was over 2 million years old.
Yes.
I don't remember where
I'm just posting that in the chat
cool.
with Science Mag. It's
Nice.
2.7 million years old on sciencemag.org, and it was discovered August 15th, 2017. At least that's the article publication.
Oh, I'll have to look that up because as
Oh,
far
wow.
as
Yeah.
the 800,000.
Yep, I'm bookmarking that run right now.
Normally, they say it's no older than 800,000 years, but they found something that comes from 2.7 million years old. And the images that they have, it comes from Antarctica. And so what we see here is it's essentially a 2.7 million year old ice core. And so in 2015, the team returned to try again to that particular area, and they managed to extract the ice core from that particular area in Antarctica. So I've posted that link in the side chat. I can post it in our chat as well, and you guys can evaluate it as you wish and have a look and see what you think.
I'll have to see if any papers are written on it. I got it open right now. They got
Likewise,
Oh, sorry. Yeah, they got it from one of the thicker ice packs in Antarctica, one of the thickest. There's a map there on it.
that is
The blue ice
wildly
area.
impressive. That's a
That's a while.
Yeah,
that's
but
just wildly impressive.
it doesn't say how they dated it.
Right. So, I mean, there's still some skepticism here. And
Yes.
Well, again, with one of the respects to the little Spider-Man thing from last week's episode, when relating to the shell configuration, not shell configurations, when looking at the actual remnants of fossilized shells from creatures that were abundant in the sea at that point in time, we can measure glacial maximums and minimums and their relation to how it affects sea life because of oxygen 16 and oxygen 18. So we do have some decent ways of providing accurate dating methods that are generally not shared in a typical report about, hey, we think we may have, because it's still just a, hey, we think we may have.
Yeah, well, like I said, it doesn't say, and I mean, I don't know. I mean, they could have done it that way, or they could have just taken a piece of zircon they might have found in it, which is a horrible way to do it, and they might have gotten it from a zircon for all I know.
True is, yeah.
This bears looking into. Alrighty.
Indeed. Thank you for the link, Mel. I'm definitely going to have to take a look at this one for a little while. That's pretty awesome.
Yeah, it's pretty neat. It's apparently a team from Princeton, but Ivy League doesn't necessarily mean anything. So.
Yeah. Well, I would love for there to be a core that old, because that goes back before the Quaternary Ice Age.
Right.
So, but, to dig into it. But, want to start the second one?
Sure. Here's your second one.
Yay!
Yay, indeed.
The last 11,000 years, that's since the Ice Age, our interglacial period, has been unreasonably stable. And we don't know why. With an enhanced greenhouse effect from burning of fossil fuel, CO2 and methane and so on, you would have a gradual increase in temperature. That's what all the models show you. It's sort of a gradual increase in temperature. But that's assuming that the climate plays nice. And we actually know from the ice cores that the climate does not play nice all the time. Right now, by emitting greenhouse gases, we are doing the same with the climate system as the investment banks in the US did when they were selling subprime loans in the economy in 2006 and 2007. In the last million years, there's been a cycle of approximately 10 ice ages. And they were sort of around 90,000 years long, each of them. And then there was an interglacial period separating the ice ages of about 10,000 years. That's sort of the standard rule of events in the last million years. If we then zoom in on an ice age, you see that inside an ice age, the climate is extremely unstable. And you have this sequence of abrupt climate changes that happen basically from one year to the next. And it swings from semi-cold to very cold, semi-cold to very cold, within very short spaces of time. But each of these cycles is about a couple of thousand years long. And we had that 26 times in the last ice age. All the big cultures in India, China, Mesopotamia, Egypt, South America, all came after the ice age. So we are assuming that this is the standard. Our collective memory refers to this as this is normal. And maybe by enhancing our emissions of greenhouse gases, we are actually tipping the climate system to become yet unstable again as it used to be. We can face a climate change that happens just as sudden as a financial crisis. We have tons of examples of climate changes where we see complete reorganization of the atmospheric circulation from one year to the next. And that will be extremely hurtful for any agricultural activity in the world, because the weather will change and will not change back. Fast climate transitions, these abrupt climate changes that we see recorded in the Ice Age, they were discovered in the Greenland ice cores. But now they keep finding them everywhere in the marine sediments, wherever they look. But when it comes to Antarctica and the Southern Ocean, you don't see them. What you see there, it's also a wiggly climate line, but opposite. So when it's warm in Greenland, Antarctica cools off. And when it's cold in Greenland, Antarctica warms up. So these abrupt climate changes, it's an internal oscillation in the Earth climate system. What if what we do now is introducing so much fresh water into the North Atlantic that the North Atlantic current would sort of stop? That would make it terribly cold in Denmark, where I come from, because all of Northern Europe is placed at completely unreasonable latitudes. Just because we have the North Atlantic current, we have remote heating, so to say. If that's going to be switched off, we're getting very, very cold. But still the Earth could get warmer on average. It's just a distribution problem now. In principle, there's no reason why the Earth could not get warmer, but still Northern Europe and North America could get cold. Still, that area is not large compared to the global area. What we know from the sudden climate changes in the past is that these abrupt changes represent a reconfiguration of the entire atmospheric pattern. What if, with the emission of greenhouse gases, that we trigger a situation when this system all of a sudden goes into a feedback? If you reconfigure the transport patterns of high pressures and low pressure systems over North America and, for instance, Europe, but particularly North America and the Midwest, and all of a sudden it stops to rain, and it hits the Midwest in the US, and it leads to massive crop failure, that's going to impact the entire world. We don't know. We don't know where the threshold is. But we are rats inside the experiment.
Okay, that's it. Pretty much.
Alrighty.
The thing I like most about that video is it kind of explains the whole, like we were talking about before it started here, the whole distribution thing. Because when people just hear things like average global temperature rise of a degree or two, they're like, oh, no big deal. But it's, it can get extremely warm in one area and extremely cold in another. And that was, I think, the most important thing to take from that video.
I absolutely agree. It's again, that one unit of measure, it seems so small, it seems so trivial, but it's not trivial. And when you consider yourself, if you're sitting around and you're 37 degrees centigrade, because that's 98.6 degrees Fahrenheit, or I might be off a degree.
No, it's exact. I'm pretty sure.
I think it's 30. Yeah, I thought it was 37 centigrade is your average body temperature. So when you up that 2 degrees, you would be walking around with a fever of over 102 degrees. You'd be completely debilitated. You wouldn't actually be able to walk around. It would be difficult to get yourself to emergency medical services with 2 degrees centigrade increase of your body temperature.
I had 105 fever with the flu, and I spent 2 nights in the emergency room because they're like, you should be drinking more water. I'm like, okay, I do, and it evaporates. What do you want me to do about this? It's like,
Yeah,
my body has decided that it's trying to die right now. So it's
a couple of degrees doesn't sound like a big deal, because from summer to winter, of course, we fluctuate 30, 40, 50 degrees, depending on where you live on the planet and which unit of measure you're using. Please don't use Kelvin. That's just going to make everything more messed up. But
that's something
but you
like
just
important. We're talking
235,
about
right?
and stuff.
oh yeah, a couple of degrees is a big deal when it comes to how life is able to function. So when all of the ocean, and consider the amount of volume that the ocean is, when all of the ocean warms by 2 degrees, that is a tremendous amount of energy being displaced. And that's actually a tremendous temperature change. You're talking billions upon billions of gallons of fluid being warmed by enough that if it warmed your body to the same extent, you would keel over dead.
Yeah.
It's a tremendous amount of energy that's being displaced, and it's difficult to think about the temperature increase as an energy kind of, I don't want to say energy differential, but it almost kind of is an energy differential, because there's X amount being put in and X amount coming out.
Mm-hmm.
And now there is X squared going in, but there's still only X coming out. So there is a differential there, and yeah, that's just basic temperature.
What was disquieting about the last video is someone very educated in this field is saying, yeah, we're not really sure when feedback could actually start. We're not. We may be there. We may be there now.
Well, yeah, we very well could be. I mean, there's as many data points as we've been able to assess at this point in time. It's still such a minuscule amount of time, knowing that the last Tyrannosaurus Rex to walk the surface of the Earth is more closely related to human beings in age than they are to the Stegosaurus, means that we have a very, very small amount of data points to analyze.
Yeah,
and our recorded history is even smaller than that. So we have a huge resource.
And compared with a human lifespan of a whole whopping 80 years, it's really hard to fathom such changes, you know? I mean,
it really is.
I mean, we live so short. I mean, we don't live very long, and we just don't see it, so we just bury our heads in the sand and go, "Oh, it's not happening." But Jamie brought up an excellent point, and I forgot the Earth only cooled by about 5 degrees Celsius, and that was enough to have the ice sheets advance from the north. So you don't need huge net average change in global temperature to push the system.
Indeed, we're surprisingly delicate for as for as industrious, for as adventurous as we are, for everything we're willing to put ourselves through personally, to go and explore, to leave the surface of the Earth, to go to the moon, we are a very adventurous species. And it's awesome. I love it. I love being a part of something that's so advantageous. But we're so young.
We have such a short,
we are.
we have
And our
such a short
civilization
attention
is even
span.
younger. And our technology is even younger than that.
Indeed. Out of our whopping, out of our entire existence, maybe 1/100% of it has the technological advancement of the Industrial Revolution onward.
And that's what's kind of pushed us towards this downfall that we're going through.
Well,
right
I think
now.
part of it too is people just assume technology is going to fix everything. People watch too much Star Trek and don't realize technology is not a magic wand. But if you also don't have the will to invest in that technology, it's just not going to happen, even if it's there.
Wait, Stephen, you confused me.
Indeed.
There was something in that sentence that confused. Did you say too much Star Trek? You lost me there.
Oh, you're right. There is no such thing.
All right.
Sorry
for the interruption.
While I agree with both of you, there is no such thing as too much Star Trek. There is something that we are also producing way too much of, and this is both a naturally occurring phenomenon and a man-made phenomenon. The man-made portion of it, there's a possibility that we do have the ability to control and utilize for our own benefit. And unfortunately, the naturally occurring side is something that we probably chose to ignore up until very recently. And now that it's reaching the potential for cataclysmic effects, it's kind of hard to ignore, but it's not given the recognition that it deserves for the fact that it is a natural occurring cycle of our planet. And even though we are impacting it, we have zero control over how it actually winds up being played out. And in that regards, what I'm talking to, since that was that wasn't even a pretty aloof description, that was a horrifically aloof description. I'm talking about methane buildup in permafrost.
I
can't
tell
if you're laughing now or...
It's between interacting with the side chat and talking to you guys. I think I have my organic molecule set over in the next room. I can go and build a methane molecule. It's literally one carbon atom and 4 hydrogens. Such a small...
Yeah, it's CH4.
Small molecule. Yeah, exactly, CH4.
It's natural gas. It's
such a small molecule can cause so many problems.
Indeed it is. So...
Yeah, those pesky tiny molecules, they're so guilty of stuff all the time.
Like absorbing heat and, reflecting it back. That's a problem. So, it's weird how it works. You have, actually, I did a show on this past Saturday. I discussed thermodynamics, which is essentially how everything works. So,
gotta love heat transfer.
Yeah, heat transfer. So when we're talking about climate change and we look at molecules, how they absorb specific, heat, and it just holds heat into our atmosphere, and methane being a massive proponent of that. But that's not the largest issue, because of the fact we have so much carbon dioxide. That's the thing that's holding the majority amount of heat in, just by sheer amount of carbon dioxide in our atmosphere.
Oh yeah, and there's when you start talking about several gigatons.
Yes.
And then you consider the possibility of, if we lost all of our permafrost, yes, methane is going to be a very, very dangerous aspect in that, but as well as with what you're stating, the carbon dioxide levels within permafrost are staggeringly higher.
Yes. So the more methane we add to the atmosphere, the more rapidly our global warming issue will become a problem, because that holds in more heat than carbon dioxide does.
And there's still plenty of carbon to be released as well. So it's it's kind of a twofold. I'm going to punch you in the face and boil your oceans away. Not literally, obviously. I mean,
it's more like we're punching ourselves in the face and boiling our own guts.
Yeah, for some reason, all of a sudden, I just saw like Captain Planet from the early '90s. Earth, Wind, Fire, Water. I hope I don't get a copyright strike for saying that.
Actually, we're talking about CO2 and methane as greenhouse gases, increasing temperatures, and all that sort of thing. I wonder if we take it one step further. There is a gas that's actually responsible for a hell of a lot more of the heat retention than either one of those at the moment.
It's water.
Yeah, water vapor. And if if we keep kicking things in the backside with the CO2 emissions and temperatures do climb a little bit, gee, maybe more evaporation. Maybe we're getting closer to a tipping point. Here's the thing with water,
though. Even though water is water vapor is one really good, retains heat very well. The thing with it is it's involved in the water cycle.
Yep.
So if it's taken out of the atmosphere quickly, the heat also dissipates quickly. It is a very good greenhouse gas, but it's not as prevalent and as persistent as like CO2 would be.
Indeed, and
I
was just thinking
water has to eventually return to another state. It does have a high heat capacity.
Agreed,
because it's water.
Yeah, but if you are constantly pumping it into the atmosphere and it's not going anywhere else, then yeah, it can hold a lot of heat for extended periods.
That's what I was thinking. If we do have some temperature rise, that might equate to more water vapor hanging in the atmosphere. Just a thought. Just in case things weren't dim and gloomy enough, I thought I would throw that.
And that's already actually been one of those things that is documented as of late, with some of our hurricane cycles being much more powerful than they have been. I don't want to spend too much time on it, but let's take a look at Hurricane Andrew and how devastatingly powerful that storm was to the United States. It was horrible. And let's take a look at last year's hurricane cycle. Kind of made Andrew look like a child.
Yeah.
There were more of them. They were more powerful, and that's happens. It's part of the fact that there is more water in the atmosphere. So as we melt more fresh water, we lose more of it from ice caps. It evaporates more rapidly from the ocean surface due to the fact that there are these fun things called isotopes, and oxygen-18 likes to stay deep in the ocean. Oxygen-16 likes to evaporate faster, it gets hotter faster, and it travels further faster. Now we have storms that are much more powerful because they have more water vapor.
We had a good time with Sandy out here.
It's more water vapor by two neutrons. No, neutrons. Good God, what am I talking about?
Well, there's neutrons in water, right?
It's a good place to keep them.
It's a very minute difference. I apologize. It's been a really fun weekend, but yes, it's a very, very small difference. But that minute difference is enough. It doesn't take very much. We are a very delicate system. The entire Earth ecosystem is very delicate, and it doesn't take a lot of change for a lot of chaos.
Let's see.
But aren't humans indestructible? That's what I'm always told.
The laws of physics and thermodynamics do not apply to us, clearly.
Well,
we have the movies and TV to tell us that.
Hey, a lot of our ability to survive has to do with our generally bad attitude as humans. I mean, we go places we don't belong, bottom of the ocean, space. I think our
exploratory type of fantasy world that we consistently throw ourselves into, it's completely our fault.
Well, Andy, you've got a couple of videos to present as well, do you not?
I do, actually. I do believe it might actually be time for epic cow farts. And no, I'm not saying that there's actually going to be cows farting or anything of that nature, but it's something that was teased and joked about in the past in the late 90s, and I've always kind of held it with me because it's a funny way of bringing up the topic of natural gas, because
the other natural
you can
gas.
call it natural gas or you can call it CH4. I don't care. There are certain places on the planet where it is much more prevalent due to the nature of decay in organic compounds. And unfortunately, thanks to everything getting a little bit warmer year after year, there are now regions of our planet that are experiencing immense levels of decay, and yes, super cow farts.
Yay, super cow farts. I'm excited.
Makes a kick-ass fuel, doesn't it? Anyway.
You think it does, yeah.
Methane, yes.
I just hear them.
Or, I can see this fueling any kind of DeLorean for Back to the Future.
That was a trend in the 80s. People were building methane generators in tanks in their backyards for fuel. Well, it was a small trend, but
even this day and age, there are actual experimental methane generators running out of landfills. Once fully covered over, okay, CH4 is going to be produced. It's a decay process. It will be produced. There's a reason why we have super tankers that are the largest ships on the planet just floating around the ocean that are full of natural gas, not doing anything.
All right.
But I'm not a proponent of any sort of energy mechanism this way, that way, or the other. But yes, it's dangerous what's happening right now.
Indeed. All righty. Ready for your video number 1?
Indeed.
And here it comes.
The last 11,000 years since the Ice Age.
That.
This our
like the right one.
That's not the. Andy, what the hell did you do? Here we go.
We tend to think that the world is very large and that we can do within it what we want, and that biology and biophysics and the biosphere will continue to work as it has in the past, that it's large and substantially immune to disturbance. That is absolutely not true. It's being disturbed at the moment. The fact that the Earth is warming as a result of human activities is a really terrifying fact.
So we look at some a little bit more sophisticated model than just a straight line, which I showed before, for the entire northern hemisphere and permafrost temperature and distribution. And this model used kind of moderate climate warming scenario. It was from the previous IPCC. It's a A1B, so it's kind of about probably 4.5 scenario. So it's not the worst, almost the best actually. And what we can see by 2050, according to this climate scenario, permafrost, all this red is permafrost is thawing. It's already gone from the surface. It's somewhere still maybe deeper, but few meters from the surface down, there's no permafrost already by 2050. So by the end of the century, well, about half of permafrost will be thawing. And that's moderate scenario. And even this kind of green, the blue areas, it looks like it's safe and stable. Well, it's not, because in these blue areas, there will be increase in summer thaw. And this increase in summer thaw will get into ice and develop some processes which are not reflected in this model, like thermokarst, thermal erosion, slumps, and so on, so many things which actually can produce some sudden changes in permafrost, sudden thaw of permafrost. And that's, it'll be in many places in that blue area. So blue area is not safe either. Now, the same model can be used just to illustrate what we can imagine, what we can aim for in terms of warming. So 1 degree of warming in the Arctic, I'm talking about Arctic warming, not global, will start thawing permafrost in this rim, southern rims around the permafrost area. So 2 degrees warming, and 3 degrees warming, and 4 degrees warming, and 5, and probably that what will be kind of realistic for that Paris Agreement, about 6 degree warming. So that's what will happen to permafrost if all these problems and obstacles Paris Agreement will be implemented. Permafrost, well, it will not help too much to keep permafrost at the bay. So half of permafrost area will see thawing of permafrost with all these consequences.
Whether we can do 2 degrees without carbon capture and storage, if we look at the IPCC Working Group 3 scenarios from the 5th assessment report, 87% of all the scenarios that are consistent with a 2 degree warming use negative emissions of some sort. By negative emissions, we mean greenhouse gas removal, so removing greenhouse gases from the atmosphere. Most of those scenarios use bioenergy with carbon capture and storage. So carbon capture and storage is central to many of the projected pathways to reach 2 degrees Celsius. And not only this, it's not only carbon capture and storage is not only an important technology for BECCS, but if we're thinking about the continued use of fossil fuels, as we phase out fossil fuels, we're probably going to have fossil fuels in the mix in 2030, still a fair proportion in 2030, and going out to 2050 as we begin to phase fossil fuels out, there's still going to be some fossil fuels in the energy mix. So given the fact that they're going to be there, it seems ridiculous to me that we wouldn't try to use carbon capture and storage to prevent some of that CO2 going into the atmosphere. So whether you believe in large-scale bioenergy with carbon capture and storage, or whether you think that we should be phasing out fossil fuels more rapidly, in my opinion, we need carbon capture and storage to reduce those impacts. And indeed, the excellent paper by McGlade and Eakins in Nature in 2015 shows that without carbon capture and storage, then we are in serious trouble.
The real wild card is the third one. Hydrates, gas hydrates, and free gas below permafrost. That's a big risk, very unknown risk, but potentially very, very serious. So, but there's some new phenomena. It's those craters, which are actually could be the conduits of methane from below the permafrost into the atmosphere. And well, I don't have too much time. I will just show some slides just to impress you, and if you have questions, I will explain. So several of them just suddenly appeared in the Yamal Peninsula about 2 or 3 years ago, and it's about 30 meters in diameter and 50 meters deep. Look like this on the wall. It was actually erupted, those things, and pieces of dirt was thrown by 100 meters away from the crater. So it was huge pressure in this thing, which followed down. And now in the winter, people get into it, and how it looks like. It's already half filled with water, during the summer, and that's interesting thing. So when they discovered this hole, they measured methane concentration in the first summer after it happened, and it was 6%. 6% of methane was on the bottom of the hole. So it is related somehow to methane, and it could be a source. Of course, if it's just few of them, they're no worry, but we don't know. Maybe they will became very, very common. So now there's some, or at least 7 of them was happened. 7 in West Siberia in the north. It's on the map here in the red dots. And what is interesting that before it looks like small pingo. I don't know if you know what pingo means, but it's kind of hill about 40, 50 meters in diameter, 10 meters high. And then, see, this is very high resolution images. So that was right before, well, in 2010. So, and then in fall of 2013, it's erupted, developing a crater. So that's kind of remote sensing pictures of that. And by now, after all time, it's just becoming a lake. So this is the latest images, here, yeah, this is the latest from the last summer, and it's just lake. And we have thousands of hundreds of thousands of lakes there. So maybe some of them really this kind of origin. Yeah, it surprised me, definitely. And it surprised, the question was if this new estimates of degradation of permafrost it surprised me pretty much. It's short, yeah. And I start answering, yes. It surprised other people as well. It surprised them so much that they don't believe in that. And even permafrost scientists, they would say, well, no, it's impossible. Permafrost on the North Slope will not start to thaw anytime this century. But this, being more realistic, well, if you can say this, more realistic about climate scenarios, but at least range of them, we see that at some range, like more like 8.5, for example, scenario, will definitely start thawing permafrost on the North Slope of Alaska, and it will be happening at least at the half of the area of the North Slope. So it is very surprising.
So, one of the things that I really like about this video, and when it comes to methane production as a whole, it's one of those, we really don't actually have any control in any way, shape, or form. We can choose to stop building... Sorry.
Oh, I was just saying, not on a singular level, no. It requires massive amounts of groups of people in order to stop things.
Yeah, we can stop using fossil fuel whenever we want. We have the technologies, we have the ability. Of course, there's the economic,
like
blah blah blah. But when it comes to methane production, we don't control when termite mounds go haywire and they start devouring massive amounts of cellulose. They produce as much methane on average, from the last time that I looked into it, as a decent-sized cattle herd.
Jamie wanted to know if cow belches release more methane than their farts. He did. He asked.
Yeah, honestly, that's actually a completely viable question, and I probably asked it myself at several points in times in my life, and the answer is no. Methane is a product. It's a byproduct of digestive processes taking place when breaking down cellulose type matter So it's not going to be on the front side of the digestive system. It's going to be on the opposing side of the digestive system.
Excellent.
Politely
The
put.
end products, as you will.
Yes.
Yes.
I just have one major thing about the video we just watched. That guy is really over optimistic, thinking we're going to be off fossil fuels in 15 years.
I would agree.
Well,
Yeah,
I mean,
that's-
we'd have to really change our lifestyle because, yeah, we have a lot of alternative technology, but you can't run an 18-wheeler semi-truck off electrical batteries. You just can't do it.
Well, yeah, not even close. I mean, the power density of gasoline, and if anyone's wondering, I don't think we need to go into it because there's been plenty of other people all across social media that have done this. My particular favorite when it comes to the energy density of different storage devices would actually be Isaac Arthur. A phenomenal channel. He's done great work with Curious Droid as well. They've actually teamed up, and when it comes to sitting down and actually looking at the energy potential per unit density, they've already made an amazing series on that, so I don't think that we need to cover it here, but if you want to take a look, I would suggest those channels. They've done a great job with it.
Can someone link it in the chat for everyone or something?
Yeah, I'll try and pull it up real quick. Actually, Arthur actually I think he just put this one out a couple of days ago. I don't know how many people follow different people, so sometimes I bring up names that I don't know if anybody else has looked at. I will do my best there. In the meantime, Sidestrike, there was a mention about carbon collection and things of that nature, and sometimes that can sound a little bit sci-fi. So while I look for this information real quick, would you mind sharing the next video that kind of helps elaborate what it is that carbon collection systems are and how we might be able to utilize them, hopefully, in the more near future than later?
I would not mind at all. And here it comes.
Yay!
Yay, indeed.
Carbon capture and storage, or CCS, is an important new geoengineering solution to climate change. The idea is simple, that we capture CO2 from large point sources, like power stations, cement factories and oil refineries, and store it or dispose of it deep underground. This stops the CO2 from getting into the atmosphere. But we want to know that CCS works, and most of all, that it's safe. CCS could be an industry the size of present-day North Sea oil within a few decades. It's simply the reverse of the oil and gas business, putting climate-changing CO2 gas back in the ground after fossil fuels have been burnt. This new technology is one of the ways that Britain could reduce its emissions, as well as help other big CO2 producers reduce theirs. Point sources would be connected in clusters to pipelines that would take CO2 across country and offshore to wells where it can be injected into former oil or gas fields or deep aquifers. The argument is that if the underground storage structure is good enough, the gas will stay there for millions of years, just as natural gas does. Scientists have already shown, at a small scale, that they can capture, transport and store CO2. In Britain, we're lucky in being close to one of the largest areas of potential storage for CO2 in Europe. The rocks under the North Sea could absorb about 22 billion tonnes of CO2, which is 180 years of the UK's 20 largest point sources. This is a really hefty reduction in Britain's emissions. we're very confident that CO2 won't leak. One of the reasons why is that we know a lot about natural gas, or methane, in the North Sea. We've been extracting natural gas from the North Sea for many years in this country. And as geologists, we know that that methane or natural gas has been in those structures for literally millions of years. It's actually stayed put for millions of years. So if we engineer the structures in which we hope to store our carbon dioxide to the same level, there's no reason why they should leak at all. The CO2 should stay down there for millions of years. We're also very confident from the science because, for example, we've been injecting CO2 for a long time. There are various places in the world where CO2 is successfully injected into rocks. For example, in the United States, CO2 is injected for enhanced oil recovery in oil fields, where it flushes the oil, the last remaining oil, out of fields. And also in the Sleipner field in the North Sea, we've been injecting CO2 for well over 10 years, very successfully. Finally, we feel that we can image, or we can actually see the CO2 collecting in reservoirs using very sophisticated seismic techniques. We can actually see the layers of CO2 as they collect. So overall, the science gives us a lot of confidence that our containers, the structures where we hope to store CO2, will not leak. The UK is taking a lead in CCS worldwide, both in terms of British government support for CCS, but also because British scientists are exporting knowledge and expertise to big emitters in the developing world, like China and India. Large-scale CCS can't happen until we know that it's viable and that the CO2 won't escape. Would money spent on CCS be better spent on renewable energy like wind farms? Is CCS a big opportunity for the UK? These are reasonable questions to ask. To answer them, scientists are working around the world to find out whether CCS is a viable long-term option.
Excellent.
Indeed.
Can I make a couple comments real quick?
Comment away.
Sure, go for it.
Okay, he mentioned point source pollution, and people might not know what that is. Point source pollution is just pollutants that come from a single identified source, as opposed to non-point pollution, which is just kind of a diffuse thing from many different sources that kind of all end up in the same place, so you can't really pin on who did it. And carbon sequestration, I believe that's how it's pronounced. I'll talk about that later. Does anybody else want to say anything?
I'm good.
I can't think of anything
Okay.
at all.
Okay, is Andy there? Andy, you there?
Andy is in fact.
Yes, I'm still here.
Oh, carbon sequestration. I think that's a good idea in part. Illinois actually has been involved in trying to do this for a very long time. This comes into the geology part, trying to pump carbon down into the Cambrian sandstones, which are deep in the basin. But the problem I have with that is that people also use this stuff for drinking water. And the fact that people use these layers for other things, you could possibly create a situation like you do with gas reservoirs, where they store gas underground in like a mini structure, like a tiny limestone dome or something. And then somebody goes and drills down a well for drinking water, and all of a sudden they've got gas on the surface. That's my main problem with that, is that it could potentially be released catastrophically.
I can definitely see that.
So, all right, I'm done babbling.
Hardly.
No, you're fine. You're fine.
Mhm.
Could hardly be
I
described
didn't
as
see
that.
that as babble, so hey.
Yeah, I see that as points of information that we should actually consider, not babble.
Indeed. Most intrigued. Andy, I'm glad you brought that topic up. That is something I've not given a lot of thought to. I've been mostly thinking on the production side, not on the what to do about what has been produced side.
Well, it's difficult to consider what to do with what has been produced, because within the natural order of things, we wouldn't chop down rainforests.
Hmm.
Yeah,
we would have natural carbon emission absorption entities that exist on our planet naturally that want to do this for free. And even most of them want to provide us with food as well. So, you know, sometimes it's hard to... It's not so much fun to think about the fact that we destroy our own self-sustaining food source so that we can have a self-sustaining artificial reality.
Okay, a line
all set aside.
a line in the public chat, I had to make sure I read it correctly. It actually says, science hasn't improved anything. Medicine, agriculture, or tech.
I was just responding to that.
Okay, okay, carry on.
Yeah, I saw that.
It's like, what is going on with that? Like, are you certain? We developed germ theory, so we know we need to wash our hands in between touching people.
Agreed, and not to mention, I don't know about the rest of you, but I personally am lacking severely in polio. So
yeah, vaccines.
Oh yeah, I know.
They're
lucky enough for me. I was never unfortunate enough to even catch polio because it was dealt with.
Same here.
Well, I was turned into a newt once, but I got better.
You got better.
Yes, Monty Python. I love it. I got better. Burn the witch. Now, I would be burned like 100 years ago. It's like a legit thing. I probably would have been burned 100 years ago because I know things and say stuff.
Well, 100 years ago, I probably would have died of natural causes as well. When I was 16 years old, I got bacterial meningitis, and I was given a 2% chance of survival. Well, I'm here, so I beat those odds.
Well, 200 years ago, I would have died just for my appendix.
Jamie.
Going.
All right, yeah, I object to the statement that science.
I think it's funny when. Oh, sorry, did I walk over someone?
Carry on.
No, I just think it's funny when people get on the internet and bash science and say government doesn't produce anything. Do they not realize the irony in that?
Right.
Wait. I know the answer to that. No, they do not.
So this person's like, am I wrong? I'm like, then don't go to the doctor. It's like, don't go to the doctor ever. Because the whole reason we have medical science is because it's built on itself. We have germ theory, we have vaccines, we have treatments for particular ailments that we didn't understand previously, but we do now. That's kind of what science does. It self-corrects and progresses towards trying to better ourselves. But, you know, hey, if you hate science, then stop yelling about it on your smartphone that was created by science. So,
right.
Oh, and
taking the easy way out and using your Velcro shoes because we needed a way to make sure stuff didn't fly off the side of an Apollo spacecraft.
So mad about my, you know, I'm going to yell at people about science while I'm on my like my smartphone right here, and I'm going to yell at people. Science is wrong. As I use science to like say how wrong science is.
Well, we discovered Velcro has a great use today. The soap dispenser on my sink kept falling off, and Sarah actually got the brilliant idea of Velcroing it to it, and now it doesn't fall anymore.
Velcro's an absolutely amazing way of making a material.
Yeah, dude.
It really is.
GMOs have popped up in the chat.
Okay, they're
everything you eat is genetically modified. This is so funny because you're like, genetically modified things. Like, what do you think selective selection is?
Yeah,
we've been genetically modifying foods for like
everything about horticulture for the entire existence of mankind farming has been genetically modifying organic stuff to
do what we want it to do for like thousands of years. Corn, naturally growing corn is like no larger than my thumb.
And
okay, it's like that's how tall it is.
And there's bananas.
That are big as your face.
I understand where people might not want to sit down and eat genetically modified organic material because they're unsure as to how it's going to react or interact with themselves. That's fine. You go ahead and eat whatever you want, or don't eat whatever you want. There's a lot of things in the world of GMOs that have absolutely nothing to do with edible foods. If we need massive amounts of organic biodegradable oils that we can use in the metalworking industry so that we're not polluting the world with actual hydrocarbon-based cutting fluids, what's the problem with making soybean oil into a metal cutting fluid instead of using hydrocarbon-based cutting fluids?
That's agreed.
It's biodegradable.
Don't forget, there's one very
It's non-toxic.
There's a trade-off at some point in time. You know, and that's the thing where I've learned in the science industry, if you want to speed something up, you're going to lose either quality or amount. So
inevitably we're going to lose something.
You're going to lose something.
We're also going to gain.
Exactly. Where your loss is going to be and where your growth is going to be. So.
Here's the thing too with GMOs. First of all, Buster is one. He's awesome. and see, GMOs have really helped, increase the longevity. Just to go back to food ones, to increase the longevity of food. And, we have an ever-growing population, and no one wants to ever talk about that. They immediately take it personally. So it's like, what do you want us to do? We can't feed the world off organic gardens.
Exactly.
Indeed.
Yeah, we can't.
Quite true. And what the GMOs, it's that I understand. Let's look into it. Let's make sure we're not producing something that's going to have unintended effects at some point. I understand that.
Yes.
What I object to is the fear, the scare tactics that are going to be thrown in to the mix, because that never has good results. You can't think clearly if you're being motivated by fear. And I don't know, has anyone seen the latest Triscuit commercial? I'm pretty sure.
No.
I have not, but I will look it up now that you brought it up.
It's and and there's a nice young lady who's indicating that Triscuits are non-GMO. I am also not genetically modified. Now they didn't say it, but they're implying that if you consume anything that's been genetically modified, somehow your genes are going to somehow be modified as well.
That's not how it works.
Agreed.
No, the entire process of evolution means that every single one of us is genetically modified.
That's why that commercial annoyed the heck out of me. I'd like.
Mel, can you explain mutagens to people and what actually mutates genes, please?
Okay. So if you eat a thing, pretty much anything you eat, you're going to have it break down in your stomach at some point in time. And you have hydrochloric acid is going to break it apart and it's going to say, oh, here's protein. We're going to put it over here. That's one of the things that pharmaceutical companies have to overcome is whether or not they're going to make a drug that's entered into your mouth or injected. Because when you eat something, it undergoes different biological processes than if you just inject it into yourself intravenously. So if you're talking about food, you're not going to inject corn that's been ground up straight into your veins. So it's not going to have the same effect on your body as if you eat it, because it goes through different biological pathways. All right. So if you're talking about genetically modified things, the only way you could actually be affected by something that was genetically modified is if you were exposed to some kind of carcinogen or virus or something that has a direct effect on your genetic code. Carcinogens being like asbestos.
Or benzene,
UV,
gasoline.
Yeah, specific types of chemicals that we know directly affect your genetic code. And, a lot there, If we look at women, cervical cancer is caused by a freaking virus. It's not caused by some chemical. It's caused by a virus that men can transmit. There's no test for men because that would be exceedingly painful to try to develop a test that removes portions of their skin off of highly sensitive areas to determine whether or not they have the RNA for this particular virus. So I get a lot of stuff coming at me on the internet about that. But you have to have something that's exclusively affecting your genetic code, whether it be in the form of proteins that are signalers that initiate RNA production, or altering in some way, and when DNA is undergoing synthesis in the form of, when you're talking about DNA replication, that sort of thing, that's not going to be found actively in just standard run-of-the-mill eating food, unless there's some other agent involved, being a carcinogen or some kind of virus. So, I mean, it blows my mind. Your stomach destroys most of what you eat, unless it's a particular type of bacteria, like salmonella, we know is terrible, E. coli, that sort of thing. But they also have a protective coating on the outside of their plasma membrane that allows them to be able to survive such toxic or caustic environments to where they can move on through your GI and produce all kinds of proteins that cause problems. That's a different bear altogether. But in regards to GMO, it's highly unlikely that these particular types of food items would generate any kind of signaling proteins that would cause any kind of RNA production from your cells, to where there could be possibly some mutagenic type of aspects. It's weird to me.
Indeed. But yeah, fear-driven is just not the way to go. And yeah, maybe I made too much of a big deal over that commercial, but to me they were implying exactly that. Even though she said this is not genetically modified, and I'm not either, that kind of thing, she was implying that eat GMOs, you're going to get modified.
Anything that's alive, anything that exists is genetically modified. That's what our genomes do. We modify over time to select the most favorable traits.
Indeed. At least if they can specify a method of genetic modification.
Natural or unnatural genetic modification. I don't know.
Frater has
don't want to get into it too much, but
modified in some form or another.
It's all technically natural, because if we do it, we're part of nature. We did it.
There you go. Oh, Frater has a good quote. Quote from Dune: "Fear is the mind killer." Alrighty.
That's why I encourage, go out and read something, talk to experts, talk to people that know what they're talking about, and say it's okay. You have to go back and look at previous history before we had this knowledge. We've been doing agriculture for 10,000 years. So it's like,
oh yeah, there's a very good chance horticulture was the first science that mankind developed.
So you have to kind of sit there and think. There are people that were given birth in freaking fields, farm fields. There are people that have been working in the fields for a long time. We developed a symbiotic relationship with dogs, to where we love dogs and they love us back. That's something we developed over a period of time. So we were fine a long time ago, before we introduced medical science to a degree. But just because we understand it better doesn't mean that we're incapable of surviving because we understand it. So that's something that I think people, they're like, oh wow, there's all these things here. Wow, there's all these killers. Wow, there's all these child molesters. Well, we have knowledge that they exist now. That doesn't mean they didn't always exist. That just means we understand it exists now.
We have better communication and stuff. And I was going to say something. Now my train of thought just derailed.
It's my fault, Steve. I'm sorry.
No, I'll think. Oh, hey, I don't. No, I don't. It's done. I derailed.
Would
Yeah.
some electricity help? Would some electricity help, Steve? And I think I know.
Maybe, but hold
I'm
on.
here. Hold on. Wait. I'll fix Steve. Here we go. Are you fixed yet, Steve?
No.
I have my sonic screwdriver.
I know
I'm
what I
trying to
wanted
fix
to
you.
Oh, he's got it.
People need to stop demonizing professionals and getting their science from talk show hosts and politicians who can't find their backside with both hands. Those people don't know anything about anything. And you should be careful.
Dr. Phil is not a real doctor.
I know.
Sorry.
You should also be careful with science media. There are some good science media sources out there, but there are a lot of sensationalized ones. So you got to be careful with that. So I think that's what I wanted to say. Zap-Zap?
If you do, okay. I was compelled by Steve says he's needed a fix of the latest Zap-Zap. So
I would like to see some Zap-Zap as well real fast, but I also need to get back to those jalapeno poppers that started cooking an hour and a half ago.
All right.
Wow. And you're not sharing? I'm so upset, Andy.
Well, how am I going to put a jalapeno popper through a digital...
You can try. It won't work.
You know what?
Okay, if I embed teleportation, then I will absolutely make that happen.
What if we genetically modify them to be self-motile?
A little
late. You can just walk to my house. Not.
I don't actually have any way to respond to that, Strike. I don't.
I'm sorry, that one was.
I believe you won.
Or maybe they can propel themselves to the air by cow farts. Can we GMO that?
That is also.
I don't want cow fart delivered jalapeno poppers. That just completely destroys the the appeal.
Understandable. All right.
Cow fart delivered jalapeno poppers at your doorstep via Andy.
Okay. Apparently, Eat Meal is not thrilled with the concept of jalapeno poppers running across the countryside.
Well, it's a good thing that they should be small enough and fast enough you won't notice them.
Yeah, but then you'll run over them driving.
Cover of night.
It'll be a sad thing. All right. Yes, Stephen has requested an update on the zappings. So here we go. After initial construction, it was basically a failure and it had to be modified, not genetically, in the process. So here's the latest zappings. Aptly named the Tower of Death.
Tesla coil.
This would be the major failure. Arc over. Very bad. Fixed!
Yay!
Nice.
Yay! Tesla coils. We like Tesla coils.
And here it is. Abusing a chandelier in the train room.
Tia would be proud. She wants the swings from those. So you just zapped it with electricity.
Can you call this a phallus of despair?
I am rather impressed with this one.
What is it hitting?
This same chandelier. Just I was goofy enough to operate the device in near complete darkness, and learned something too when operating it in complete darkness.
Don't lick it first.
No. It's completely different from that. Not completely different, I guess. When I start the sentence, you're going to know where it's going. You know what? I'll just say the start of the sentence. Wire-rimmed glasses. Do I need to say any more?
Oh.
I don't need to say any more, do I?
No. Do you have footage of this?
No. There is. That was the end of that. There was a video where I was just a little closer than this, taking a beautiful shot of the arc. Had a nice corona around the arc. It's about 20 centimeters, which I think that works out to what, about 600,000 volts or something like that. Anyway, had a nice video because I wanted to catch the corona and catch each little tendril of the arc and all that sort of thing. And right in the middle of it, you just see the video back up about a foot.
Oh,
that would be when things occurred. So,
Excellent.
having recovered from that, I'm here to join all of you fine folk. Anyway, oh my, we went long today. Look what time it is.
oh
We
wow.
started about 15 minutes late, 2 or 4.
Yeah, you guys are entirely too interesting. It's your fault.
Tornado Pelt goes zappity zap zap. Yes.
All right. Yeah, that's this. That is it for the update on the experimentation going on over this way.
Excellent.
But
I can
Very
go
awesome. I should have the new MMC built for mine shortly. It had a little bit of a, buying the new truck, I had a expense amounts had to be adjusted.
Understand. Oh, and another thing I learned with this one, quite by accident, I fired it up before adjusting the spark gap. It was a very small gap. As you know, the distance between the two electrodes in the spark gap is what determines what your maximum voltage is going to be before it discharges. And we had, both of us, been experimenting in the past with the longer gap to get the higher voltages. This is actually the input voltage to this is probably about a third of what all the previous ones. This one, the input voltage to that primary coil is about 10,000 volts. And by the way, the primary coil, I don't know if you noticed, the coil form is a kid's beach sand pail that I got from Walmart.
Yay!
Whatever works.
If you want to go sciencing, Walmart is a good place to start. But
to
unless
be
you need
fair,
copper, then you got to go to Menards.
I went from I've gotten new lighting, so I don't look so washed out, and I have LED bulbs like green and red, and I have painter's lamps. So I have those like set up over here, and then I have like my desktop lamp. God, words are hard right now. So it's like,
and you weren't even zapped.
I've been like officially zapped and stuff, so I completely blame Strike for his Zap-Zap before I said words.
Oh my.
But it's like Home Depot. Home Depot is primarily where I got a lot of my stuff when I was working on the breast cancer test. I would go to Home Depot and buy things.
Yeah, Home Depot.
I was like here for this.
Well,
hey.
Well, as luck would have it, across from the local Walmart is a Home Depot, where I also go. Between those two places, most of what I need to do gets done.
Menards has a great copper variety of like pipes and stuff. Crap, they even sell copper nails. I didn't even know that was a thing until I stopped in there yesterday.
Indeed.
Bo had talked about, and in the side chat has asked me like a few times about talking about the difference between selective breeding and genetically modified stuff. I can do a whole episode on that on my channel if you want. So, because I know we've gone kind of long here. So I'll add that to my polls that I do every week. So I can kind of get into how genetic modification is not that different from selective breeding. So
that sounds like a fun one to take a look at, Mel. And I'm really sorry, everybody, if I don't get back to making these jalapeno poppers. Everything's going to be cold, and it's going to be a travesty.
Sounds like
I haven't eaten it all today, and I've been waiting for these poppers all day.
I understand the need of the poppers. So
I would
sometimes you just gotta have peppers stuffed with goodness.
I agree with that.
No
disagreement. I'm gonna forever be picturing legs on these things now.
Great.
I will take some selective photography and see if I can CGI some legs in.
Ooh, yes, put gecko legs on them.
And knocking on our door. We have come to your house to deliver ourselves for your sacrifice to the jalapeno gods.
Talk to Peter. Talk to Peter. He's great with video. He's great with videos and things like that. I'll bet he could put some legs on him, and they'll look real. We'll frighten just about everybody.
I'm down. I'm going to take some pictures of some jalapenos getting worked over.
Okay.
Ooh, could you? Oh no, it's a dumb idea. Never mind.
Oh, let's hear it. Let's hear it.
No, I was gonna say, could you fry one with the Zap-Zap? Probably not.
Yeah. There's a significant amount of heat. Remember, this is not just an electrical arc. There's also a fair amount of RF energy involved. Yeah, we can cook stuff.
Oh, okay.
I'm gonna need to get a wood skewer first, otherwise I would get zapped as well, and that doesn't sound like fun.
Yeah, and what kind of goofy person would stand?
No,
close
use
enough
the
to get
copper
zapped?
skewer.
I'm really hungry right now.
For science.
I need some jalapeno poppers because I'm really hungry right now.
Oh yeah, all this food talk.
Okay, well, I am personally starving. I think this has been an absolute blast, everybody. Thanks for joining us all. I don't mean to cut anything off short, but I am seriously starving and want to keep cooking this food. So I'm going to walk away. If you guys want to keep having a hangout and doing more Sunday science, I say go for it.
I think we're about ready to wrap it up. Everybody concur?
Yep.
Yes.
Alrighty. On that note, evening has been fun, guys. This was a nice episode.
Indeed, lots of fun, guys.
Oh wait, is this the last one on climate change, or are we going to do another one?
Oh, we're good through Earth Day on climate change.
Oh, that's right. Okay.
Indeed. And
Yes.
I get the impression not everybody was thrilled with the giveaway thing, because I didn't get a lot of people filling out the form, so I'm going to have to come up with something cooler. I thought that was cool, the clients didn't.
I thought it was cool, too.
The climate denier.
I did, too.
Yeah, we'll give that away, too. But I'll find something cooler, and we'll announce that next week. All right. On that note, yeah, thanks. You guys rock. On the panel, always educational hanging out with you folks.
Absolutely. Glad everyone could join us, and thank you again, esteemed panel. You guys are absolutely phenomenal to have on the show. You're welcome back here anytime, even if this series is continuing or not.
Thanks, Andy.
Excellent. All right. Evening, all.
Night.
Good night. Bye.